Hi, my goal is to weave a little story here and introduction of the word sine and the sine ratio. Anyway, sinew is of Greek origin. It comes from the word cartilage and derives the word cartilage. And let's see, when men went to war in Greek times, they didn't have the wood from that part of the country because the wood was pretty soft to create the bows from the bows and arrows. And they didn't have the metal involved, set up that well. So what they did was they used animal bones. And within the animal bones is cartilage. It gives it that little bit of bendability that you can pull back and create a bow and arrow. So let's look at this bow and arrow. Okay, start off easy. Will I put the arrow here? No. And the reason for that, it'll be completely imbalanced. Would I put the arrow here? Again, the answer is no. Because you can't shoot it. The arrow will go straight through the middle. And that's where I'm going to start my story. Okay? So we're going to start our story with a bow and an arrow right through the middle. And let's look at this. This is made out of bone, and between the bone, of course, for the bendability, and cartilage. Okay, the string part of the bow is made out of horse's hair. You know, pretty strong, you know, from the back of the horse. And I think violin string is currently made with that also. And let's look at this. Since I put in the middle, I can say that this piece and this piece are the same. They're equal. So let's call this A, B, C. And from a previous lesson in geometry, we know we have a right angle right there. And if I want to just go around, I have a circle. So the technical definition of sine, is half a chord. And let's look at the length of that half of a chord. The length of that half of a chord of a unit circle, and before I rewrite the word, I should say we are using unit circles. What do I mean by the word unit? It's one. It could be 1 foot, 1 yard, 1 meter, 1 arm length, 1 nose length, but one. So that's going to be our comparison for everything. So I'm going to redo and redraw that unit circle as best as I can. And here you go. We have a unit circle, and this is 1. And this is A, B. O will be for the center of the circle, even though the arrow goes out here. We're working with a unit circle with a radius of 1. So I can say the length of the sine, don't forget sine means half of a chord. The length of this sine happens to be AB. Well, AB is the same thing as AB over 1. Well, if I look at AB over 1, I can say AB is the side opposite angle O. And 1, because we have that right triangle, is called your hypotenuse. Okay, so let's look what we have now. We have right here the side opposite angle O over the hypotenuse. And this is now technically going to be your sine ratio, which some people say quickly is opposite over hypotenuse. Well, along the way, in the same vein, but we're going to look at cosine. And cosine will then be, the cosine ratio will then be adjacent over the hypotenuse. And finally, let me just go through the story of tangent. Let's look at the word tangent, definition of tangent means. If I would turn around to a student and say, oh, well, we're working on such a beautiful day on the schoolwork, and then all of a sudden I notice one thing about the student, and I say, oh, I like your hair today. I like that bow in your hair. And then all of a sudden, a bow in the hair. Oh, Jill, you have such a beautiful bow in your hair, and I noticed that you played baseball. Oh, Nick, I see that you also play baseball. And I'm going back and forth. I'm picking one item, and I'm going off on a tangent. But I'm picking that one item. Well, that's the same exact thing right here. I'm going off on a tangent. A tangent happens to touch the graph, the circle, at exactly one point. So let's look at this again. I can draw it here, I can do it here. It doesn't matter where it goes. But whatever number I use, that's the number I'm going to be doing it slowly. So let's say this happens to be my A, B, and O. Again, we're working with a unit circle. A unit circle has a radius of 1. Where is my radius of 1? Right here. And this is my tangent. It's touching at exactly one point. And from a previous lesson in the geometry videos, you can see why it's a right angle right here. And at that point in time, we can turn around and say, well, AB is the same thing as AB over 1, which happens to be opposite angle O over adjacent angle O. Hence, tangent is known to be, tangent of O is opposite over adjacent. So let's look at what we did, 3 parts to it. We know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, and this is the way many people remember it. Sakatoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So let's do one example or 2 examples quickly of giving you examples of these. And I'll tell you a quick joke. Well, we're going to use a 30-degree angle. Or should I say pi over 6? Well, if this is 1, this is half, and this is square root of 3 over 2. Well, if that's the case, sine of 30 is 1/2 over 1, opposite over hypotenuse. Cosine is adjacent, so of 30 is square root of 3 over 2. And tangent of 30 is 1/2 over square root of 3 over 2. And for those of you who get confused with this, let's go through this slowly. So that happens to be 1/2 divided by square root of 3 over 2, which happens to be equal to 1/2 times 2 over square root of 3, which then allows me to cancel, which gives me 1 over square root of 3. And then since we have to rationalize the denominator, We multiply top and bottom by square root of 3, and I end up with square root of 3 over square root of 9, which is 3. These are going to be one of those that you have to memorize anyway, and you're going to know by heart, and teacher's going to give you unit circles and all that stuff, but understand where it comes from. Let's do one more example, a simple one. Let's say I gave you a triangle, a right triangle, A, B, C. Let's call this 3 and 4. Well, if that's the case, because of the Pythagorean theorem, 3 squared plus 4 squared equals c squared. C is equal to 5. So the hypotenuse is 5. So the sine of A is 3 over 5. The cosine of A is 4 over 5. The tangent of A equals 3 over 4. Opposite over adjacent. But let's also look at the next piece. Let's look at things in terms of B. Well, sine of B, opposite B is 4 over 5. The cosine of B is 3 over 5, and the tangent of B equals 4 over 3. Now let's look to see if there's a relationship here for a second. If you look at this, these two are the same. Cosine A and sine B. Sine A, cosine B are the same. So we say is eventually sine of A is equal to cosine 90 minus A, because it's the other angle in the right triangle. Now, why couldn't trigonometry get alone? Okay, it's because tangent wouldn't cosine. I know you love this sense of humor, but that's life. You're stuck with it.